Hi, I'm Kevin Hauser. I'm a full-time Ubiquiti trainer, and I'm the author of the recently published Unauthorized Ubiquiti Radio and Access Point Handbook. There it is. Yay. Available now on Amazon. Yay. The reason we're doing this video, and I'm going to do a series of these videos, is not only just in support of the book, but we're going to take a deeper dive into access points and outdoor radios. I know lots of you have watched 15 and 20 minute long videos on YouTube about how to configure a radio or an access point, what certain settings mean. We're going to go a little bit deeper into that. Absolutely. So why did I write this book, and why does it say unauthorized? All right, let's start with that part first. I didn't write this book for Ubiquiti. I didn't write it underneath their point of view. This is all my opinion. This is all my work here. You can't blame it on Ubiquiti. Any opinion expressed in the book is sincerely my own opinion, as far as troubleshooting, configuration, things like that. Things I've just sort of absorbed over the years. The second part is, I find that when I do classes on a repetitive basis like I do, you run into some of the same questions from students that other students have already had. How do I solve this problem? Or what do I do when I have that issue? Or is this the right radio? That's really common, and I've answered a lot of that in here, but I want to do some of that on the video as well. The deep dive, right? That's kind of what I want to do here. The other thing is time, money. Not everybody has time to take 2 or 3 days off to attend a Ubiquiti training class, and they're actually kind of expensive. So, I mean, for those of you who don't have the time or the money at present, this covers a lot of the material that we have in class. So, while this is not a substitute for hands-on, independent, face-to-face training, it's pretty good. So, if I say so myself, I think it's pretty good. So, this book is in large format. The reason it is because I've got a lot of graphics and diagrams and color diagrams and fun stuff like that. And I think it's super helpful to be able to see that in a visual way. Anyway, so this particular video, we're going to have like 2 pieces of this, to break it into 2 pieces. One of the chapters I have in the book near the end is troubleshooting. And what I want to do is, for every video, I want to do a piece of troubleshooting, and then we're going to go into a separate topic. So the troubleshooting part will actually be kind of brief, but to the point. And the first one I want to cover, as far as troubleshooting is concerned, is what I would consider my most common question, or my most common problem that people have had in the last, several years. It is a real basic one. All right, let me grab this guy here. The question is, how come I'm having problems adopting this access point? Why am I having these issues adopting this access point? So we're going to cover that part first. All right. So we're going to jump into that, and to do that, I'm going to show you a couple of boring slides, and then I'll narrate for that. All right, very good. All right, so let's start with the question that I posed before. Why am I having problems adopting my access point? Now, while the reasons for this are myriad, let's start with the most common reasons why. And I think from there we can move on. So let's start with probable cause number 1. So why am I having this particular problem, right? Is the device in an adoptable state? Now, what this actually means is the access point A been set to defaults? Now, if the device is not set to default and the blue light is on, or there's a blue light that alternates blue and white, it's not an adoptable state device. It has to be in the default state for you to be able to adopt it, right? So that's number 1. And I've actually seen people that had an access point that was previously adopted, and they forgot all about it, and they plugged it in and thought, why is this not working? So this is kind of the first basic. Is it ready to be adopted? Is the white light on? That white light is basically allowing a layer 2 broadcast to happen in a discovery, inside Ubiquiti's discovery tool, to say, hey, here I am, adopt me. Okay, so to make that work, right, to make that layer 2 adoption work, is the device on a live network, right? Does it have an actual IP address? Does it have a gateway? Does it have a subnet mask? These are common problems that people have tried. Oh, I'm going to set my AP up in a test environment. You really need to have it on a live network to do this, right? So, like I said, going back to the first part, it has to be adoptable. And part of that is it has to be on an actual live network for this to work. All right, so that's step one. Make sure the white light's on. Make sure it's pulling an IP address. Okay. Now, if it never shows up in your controller to be adopted, it probably doesn't have layer 2 connectivity to your controller. Right? So it has to be on that same network for you to adopt it. Now, we are going to talk about more advanced adoption and layer 3 later on in a future video, but we are going to talk about that in depth, so do not worry. Probable cause number 3 is the firmware version updated on the access point, and what version is the controller software running? All right, so recently there's been some brand new APs that Ubiquiti has out, the Wi-Fi 6 fun stuff, right? So when I first got my device out of the early access store, my controller would not adopt that device. It would actually see it, it would discover it, and it was never adoptable. In fact, I don't think the Adopt Now button even showed up on that brand new device. So I kind of recognized that I would need a different version of the controller to go ahead and adopt that brand new AP. What I ended up doing is using the app on my phone, and that actually worked fine, and I was able to adopt that. Now, going up to the first bullet point, is the firmware up to date on the AP? When you buy an access point from, wherever you buy it from Amazon or from some vendor, some distributor, you really don't know how long that thing's been on the shelf. Okay, so one of the things I've seen, I haven't seen too much of it this year, but I have seen it in the past, is if the firmware version on the access point is pretty old, then the newer versions of the controller really won't adopt it well. It'll actually show up, layer 2 works, but it never fully adopts. And that's the most frustrating part that I've seen. That's the most frustrating part that I'm sure people have, saying, listen, I can see this device, there it is, I click adopt and nothing happens, or it just goes around in a cycle and it never actually happens. Well, one of the causes was that this AP firmware version that's older than, let's say, 4.0 can't really be adopted by a newer version of the controller. Now, there are several ways to fix that, right? But let's talk about my way, which is the lazy way. It's the actually easiest way for me to do it. I actually have, on my laptop, I have an older version of the controller. What I will do is I'll fire up that version of the controller, which I said is considerably older. It's probably, a year old even. And that version of the controller will have some firmware updates for these devices. In other words, updates for these devices are embedded into the controller. So if you have a really new version of the controller, it may not have an upgrade for a device that's super old or it has problems seeing it. And like I said, this is a common issue. It happens. So one way around it, like I said, is have an older version of the controller, plug it in, stick it on the network, find the device, discover it, and go ahead and upgrade that device. Now, if you have a version of the controller that gives you the choice of adopt and upgrade, or just upgrade all by itself, just select upgrade and go ahead and update it to the version that the controller supports, right? If not, adopt and upgrade it, and then just go ahead and forget that device, and you'll be back to square one. The device will be back to factory defaults. And since the firmware has now been updated, perhaps your newer controller, it'll actually go ahead and adopt that device. All right, so that's sort of a quick and dirty 3 little things that could be wrong that you should check first before we move on. Now, what we're going to do next is actually much more fun, at least for me. All right, so cool. Let's go on. Let's move on with that. All right, so that was a quick and painless part 1 of troubleshooting. Like, why can't I adopt my access point? So the reason, like I said, I started with that because that seems to be a common question where people have an older version of the AP, newer version of the controller. And we'll talk about the controller itself as we move forward. But basically, we're talking about a big piece of software that controls hardware. Now, if the hardware and software aren't really compatible, you're going to have problems. So that's why that old and new version issue has come up in the past. But it's surprising to me, it's actually surprising that there are all these weird little hiccups that you just sort of have to get used to and understand. I remember going to a class in Oklahoma and Tulsa and setting everything up, and before I could even get started, the guy was taking some of the training. He was in charge of the rest of the fellows taking training, and he basically stood up and waved his access point at me and said, "Before you do anything, before you start anything, I want to know why can't I adopt this device?" And that was actually his problem, was the firmware version that they were using just didn't understand the device. Again, the firmware in the controller is actually holding the versions of updates as we move forward. So again, while this is not a common problem, it does happen. So just want people to be aware of that. Now, what we're going to go into today, as far as like what we're going into in the book. Now, chapter 1 of the book is physics, and I know this might bore a lot of people, but for me, if a student understands the physics of wireless, like what's physically going on, what is it doing at the layer 1, you can understand why you might have having some kind of issue or some kind of problem. It will actually help understand that. Now, we're going to start with noise. Noise is inherent across all wireless systems. And the reason I'm starting with noise is because it happens in both outdoor systems like this little Nano, and it happens in indoor systems like that AP I have. So noise is just noise, and everybody in wireless should have an understanding of what it is and how do we overcome it, how do we combat it, what are some of the best ways to do that. So that's kind of what we're going to start with, noise, okay? And then we'll do a demonstration to show you that. All right, thanks. Hold on, we're going to actually jump into another quick and painless PowerPoint. Okay, well, this should be fun. What we're going to talk about now, what we're going to look at, we're going to look at noise and interference. While noise is a little bit different than interference, for the purpose of this conversation, we're going to kind of lump them together a little bit. Traditionally, interference is sporadic and something that occasionally happens, while noise is really just sort of background noise, right? So we're going to look at the different types of noise that we have to understand to better facilitate our Wi-Fi installation in our wireless networks, right? So the first part we're going to look at is actually the most important part to me is thermal noise. So thermal noise is a type of noise that exists as a background noise in all radio operations. Of course, you can see the definition here, creation of a wave makes noise. This noise exists across entire spectrum, and it's actually caused by the movement of these free electrons that are part of a radio circuit making this wave. So unless you had a radio that was operating at absolute zero, you're going to have some thermal noise, right? So this is a common type of noise. This is also called Johnson-Nyquist noise or just Nyquist noise. This is basically also referred to in Ubiquiti as the noise floor. This is the base noise that you have to overcome, the background hum of wireless. It's always there. All right, so to show you this in sort of a 3-dimensional or 2-dimensional look anyway, I actually have a nano beam radio. So let me just drop out of here real quick and let me open up my nano beam. Here we go. And inside my nano beam, which is a $50 or $60 radio, it's not expensive, there's actually a spectrum analyzer. Okay, so let me open it up. It's under Tools, and it's AirView. Now, this AirView tool is also available on Unify HD access points, the high density access points, and the SHD access point. So once you get to that level of access point, it actually has a spectrum analyzer built in. So you'll actually have this tool, AirView. All right, so what we can see at the top of our screen here is what they're labeling the waveform view. Okay, so let me click on that real quick. So this is actually showing the entire 5 gigahertz spectrum that this radio can sense. All right, so this radio has a high level of sensitivity. Now, what we see here, a couple of different things. We see some white little peaks going up and down, running up and down, and we see a big orange band across the bottom. Okay, so the orange part is our noise floor. This is our thermal noise. Okay, this represents the background noise that this radio can sense. All right, so bear with me. These radios are very, very sensitive devices and can see very, very minute amounts of signal, and they can see noise really, really well. In fact, the larger the channel the radio is operating on, the more noise it will actually sense, the more noise it'll actually report. All right, so one of the ways in outdoor radios to avoid Too much noise is used narrower channels or smaller channels, right? That's one thing that we actually will do. Now on the second screen, this is our waterfall view. This is more of a time-lapsed view. Now I live out in the middle of nowhere, and I really don't have a lot of stuff running out here. I have maybe just 1 or 2 APs, so I really don't have a lot of wireless traffic out here. But if I did, you would actually see it here building as these colored blocks, the orange and the reddish blocks, right? So it detects this type of traffic and reports it on the bottom part of the screen here as ambient noise level, all right? So we can actually take a reading hourly or by the minute, and these little blocks will actually build up, or this you can actually see it here by the minute here. That's kind of what it's doing. And you can see that, again, this is a very, very, very sensitive device, and I can actually see data. I can actually see noise being moved around. One of the flavors of noise is the movement of actual data. That actually makes noise, right? So you can see if I hover sort of down here, I can get an idea of about where this noise goes from and goes to on the spectrum here. The reason I have this noise here is I'm sure I have one of my access points running at one of these lower channels. That's why that noise is there. The movement of data makes noise. All right, so again, the first type of noise that we're talking about is thermal noise. This is a background noise. This is something that's always going to be there, and that's just the reality of radio. And I did mention the other type, and we'll see that in a slide in a minute. The movement of data actually contributes to this noise floor. So other types of noise, including RX, TX noise, will actually kind of make the noise floor peak up a little bit. So if there's a lot of data movement, let's say on this frequency over here, around 5200, then you would actually see the noise floor sort of peak up in that location, reporting a little bit more noise in the background. So think of noise, like I said, as sort of a background that you have to overcome. The idea is to have a radio either indoors or outdoors set up with enough distance between what the radio hears as a signal and what the radio sees as noise. This is called signal-to-noise ratio. We'll actually see more of that as we move ahead. All right. So let me stop this for now, and let's go back to the PowerPoint real quick. All right. Here we go. All right. So thermal noise, the creation of a radio wave in a circuit will create thermal noise. That's what we're seeing here, right? That's kind of what we see. Noise floor, noise type number 2, in band. Now, this is, I would say this is the most common and overlooked type of noise. Basically, and you see the description, a radio operating on a particular frequency can be interfered with by another radio on the same or nearby channel. This is known as in-channel interference or near-channel interference. If there's another radio nearby, especially in the access point world, indoor radios, operating on the same channel, the same frequency, it'll create noise in that sort of overlap area. So obviously indoor access points are covering a cell area. So the idea would be to select a different frequency for an access point near another access point. You want to have a good channel reuse pattern to avoid this. Now, for the outdoor radio, you might be on a tower or you might be nearby some other vendor, and you really don't control what channel they're using, and you can't really control how often they change their frequency that they use either. So you can have interference from another radio that's near the same channel. Right? So this is a commonly overlooked type of noise, and people don't really see it all the time. Again, in Unify, you can select the auto channel assignment, and the access point will, once it boots up, will actually do a quick scan and say, hey, what's the best channel to use? And it picks a channel. However, that channel is going to stay there. Even if another nearby radio is actually installed on the same frequency, it will not automatically detect that and change its channel. So that's one of the things about in-band interference, right? So that's a type of noise that we have to overcome as well. RX. This should say RX-TX, but it's mostly RX. When a radio receives a signal, that reception of that signal is actually making noise. Okay, that's part of the radio circuitry. Okay, so again, this has to do with how large the channel is that radio is using to send and receive data. So this is a common type of noise, and again, it's reflected in the noise floor when we see that little orange band at the bottom. move up or move down. That this will affect that. All right, so this is sort of noise flavor number 3. We had in-band interference, we had thermal noise, and now we have RX noise. And again, this is kind of noise. The last part here, this is EMI. So anybody out there who's a networker knows what electromagnetic interference is, right? So the definition, of course, right there, an NIR, like a microwave oven or a motor, will create noise, right, and interfere across the spectrum. So I'm pretty sure that when they created microwave ovens, they weren't really worried about Wi-Fi because it wasn't such a popular thing. But anything that creates a wave can interfere with wireless, right? So one thing I've noticed through the years is that, for instance, microwaves, all microwaves leak. The commercial ones leak less than the inexpensive ones, but they all leak. That's just the way. That's the nature of the microwave oven. So I'm actually going to do a little demonstration on an electrical motor and show you how this noise actually happens, right? So again, this can be considered more along the lines of interference than noise, because obviously a microwave oven isn't running all the time. But in the case of an electrical motor, it may be. Now, this motor could be an elevator motor to run an elevator up and down in a building. It could be a motor driving a pump that circulates water in a swimming pool. It could be audio-video equipment. It could be television equipment. A lot of things will actually make noise to varying degrees that we have in our world. So it's frustrating for me to see an access point, for instance, mounted directly behind a television set. That's probably not the ideal location for it. But then that does happen. All right, so we're going to pause. We're going to go back and we're going to do a little demonstration, and we'll see noise in action. Okay, so we're back. I did mention that we're going to do a demonstration on creation of noise, and I thought about maybe I could take this outdoor radio and hold it near a microwave oven or something crazy like that, but I had a better idea. So I was at a flea market recently, and I bought this 60 or 70-year-old mixer, right, wearing mixer, and I'm pretty sure this still works. It's horribly noisy. It still works, and it's a motor. So I'm going to have it running in the same room as my outdoor radio running AirView, and actually we'll see if it influences the spectrum, like I think it should. That way it'll give us sort of an idea of, like, was Kevin full of it, or was he being accurate? I remember the mixer days when my mother-in-law would make potatoes or something, the TV would stop working. So pretty much that's interference. That's localized interference. But I'm going to run a little experiment. We'll capture some of this inside AirView, inside our ambient noise, and we'll actually see what it looks like. So that's what we're going to do next. So I'm going to pause the video while I do this, and I'm going to collect data. And this is just going to be running in the same room. And I'm going to let this run for 2 or 3 minutes and see how much noise it accumulates, and then we can go look at that. All right, so let's do that. All right, so I ran my little mixer for 3 or 4 minutes, and you can actually see the result here at the bottom of this AirView tool. Obviously, the wearing mixer people didn't understand that they were going to be a future problem for somebody in the wireless world. So when somebody's making the noise with this type of device, you can see that it's affected the entire spectrum here, not just one area, not just one frequency, not just one channel, but the whole thing, right? So this is an effect of a harmonic where we get echoes of this signal throughout the spectrum. So high-powered devices like this, and that's a pretty high-powered device compared to an access point or compared to a radio, can actually do this. So you can slowly see this. I've turned off the mixer for the time being, and you can see that the screen will slowly return to normal. And in fact, in the center part here, you see no more noise now, but in the bottom you can see how it had been reported. So again, this is noise. This is interference. This is EMI. This is a good illustration of EMI. So when somebody's having interference of this type, whether it's a microwave or a swimming pool pump or an elevator motor, it covers the gamut. It doesn't affect just an access point or a radio on an individual channel or frequency. And I think this is a good way to show that, even though this doesn't happen all the time. Again, that's interference. It doesn't happen all the time. So it's been my pleasure to show you a graphical representation of noise. All right, so we're done with this part. Let's move on to the next part. Okay. Come on. Let me stop you from going. God, mother. Come on. Just stop. All right, so what's the takeaway here? What did we learn, or what do we hope that we learned? Noise and interference are sometimes hand in hand. Interference is generally sporadic and more uncommon. Noise is something that's there all the time. However, both of them can affect both indoor radios, outdoor radios, and it doesn't have to be a lot to affect that device. Again, these are very sensitive devices. It can hear very, very minute signals. So how do we guard against that? In an outdoor radio world, you may have to shield your radio. You may have to put shielding behind the radio. You may have to put it in an enclosure to keep it from being interfered with. You know, when outdoor radio waves miss their target, they don't stop. They don't turn around and go, oh my gosh, we missed, turn around. They keep going, and they keep going for miles. And maybe one of those signals bangs into your radio, right? Or maybe it's a multiple of a powerful signal, right? Like radar. These things can all be contributing factors to noise, right? And it doesn't have to be a set type. In other words, what I mean by that is many times people in the outdoor world, radio world, will have noise and they have no idea where it's coming from, and you may never not understand where it's coming from. So the best way to guard against it is, again, shield your radios. Use air prism when you're on a tower with other vendors. Use filtering. For indoor access points, move them far away from these devices that are creating noise. Microwave ovens, audio video equipment, move them away. Mount them correctly. When the guy in the commercial kitchen says, gee, after we put up all our stainless steel, we're having problems with our wireless. Again, understand what noise is and understand what interference is. Can you always avoid it? No, but you can kind of minimize its impact, and that's really what we're going for here. And to understand that it's there, right? So that's part of the larger puzzle. Just understand that it exists. And even though I live out here in the middle of nowhere, and if I have an outdoor radio, which I do, it may have to be shielded. All right, so that's sort of the takeaway from today's lesson. Now, as we move forward in some of these videos, we're going to talk about more in-depth things like radar detection on an outdoor radio. Why does my radio keep showing up with a radar detect error? That kind of fun stuff. So we're actually going to look at that as we move ahead. But hopefully we have a little bit of understanding about more of physics and noise and interference, because that's something we have to really have a good solid feeling about, a good foundation on. All right, so that's all for today. I'll see you next time. Thanks for joining me.